certain basic concept of it. Okay, first of all, we define the heat and temperature. So, heat. The heat is the total sum of kinetic energy of the molecules contained in a body. So, the total sum of kinetic energy of the molecules contained in a body is called heat energy of the body. Okay. Similarly, the temperature. The temperature is the average kinetic energy. So, the average kinetic energy of the molecules contained in a body is called temperature. Okay. So, the total or sum of kinetic energy of the molecules contained in a body is called heat energy, and the average kinetic energy of molecules contained in a body is called temperature. So now from this we have another, the unit. The SI unit of heat is joule. And similarly the SI unit of temperature is Kelvin K. Or the most commonly used unit of temperature is degree Celsius. Okay. In other words, or you can write degree Celsius. That is the most commonly used temperature unit of temperature. Okay. So this is the main two difference between the heat and temperature. Okay. SI unit and definitions. So in other words, heat is a form of energy, and in other words, the temperature, the degree of hotness and coldness of a body. You can write that also. This definition is molecular definition of heat and temperature. Okay. Now, we discuss about the heat equation. Heat equations, okay? So, the heat equations mathematically, first I would write it mathematically. The heat gain or lost, quantity of heat gain or lost is the product of mass, specific heat capacity S into the change in temperature. Okay, so this is the heat equations. It is a brief. So the heat gain or lost is equal to the product of mass, specific heat capacity, and change in temperature. Okay, so this is called heat equations. Change in temperature. It's called heat equation. Okay, and it is written as Q equal to M times S times dt, where Q is the heat gain or lost, quantity of heat gain or lost, M is the mass of the body, S is the specific heat capacity of the body, and dt is the change in temperature. And this dt is given by T2 minus T1. Okay, and this temperature, the difference is depends on the conditions, whether the heat is gained or lost. Okay, if the heat is gained, suppose if it is gained, that means the heat is transferred from hot body to cold body. So if the cold body gains heat energy, at that time the initial temperature T1, okay, is smaller and final temperature is more. So you can write final temperature minus initial temperature. In case of water body, cold body, when heat is gained, when heat is gained, okay, so when heat is gained, then dt is final temperature minus initial temperature. But when heat is lost, in that case dt is equal to initial temperature minus final temperature. Okay, so in this case we write initial temperature T1 minus T2. Here final temperature minus T1. Okay, so this T1 initial temperature, T2 final temperature. Remember this. So when heat is gained, okay, in case of cold body, T2 minus T1. In case of hot body, this one, okay, T1 minus T2. That means when we brought in contact to hot body and cold body, then suppose this is a two body, they are brought into contact, A and B. One is hot, this is hot, and this is cold. Then heat is transferred from hot to cold body. Okay, this is the direction of flow of heat. direction of flow of heat. Heat flows from hot body to cold body. This is hot body to cold body. Okay. Heat always transfers from hot body to cold body. So suppose it is 100 degree centigrade, is temperature 100 degree Celsius you can write, and if it is say 40 degree Celsius, then this is a hot body, so the heat transfer from hot body to cold body. Okay, then you remember this point also, and the amount of heat lost by hot body is equal to the amount of heat gained by cold body are always equal if the escape of heat energy is negligible. Okay, in other words, in a closed system, heat lost by hot body is equal to heat gained by cold body, and this principle is known as principle of calorimetry. Okay, so principle of calorimetry states that heat lost by hot body is equal to heat gained by cold body. Okay, so one more thing that we discuss, the heat is measured by calorimeter. It is measured by calorimeter, whereas the temperature is measured by thermometer. Okay, now we discuss about the numerical problem. Look at the questions. Study the diagram and answer the following questions. So, what we see here, an iron bulb at 100 degrees Celsius is dipped into the water at 20 degree centigrade. We see this. Okay, iron bulb at 100 degree and water at 20 degree centigrade. So, what is the questions? The sub question. There are three sub questions. The first one is write the direction of flow of heat. So, as I have already discussed this before, the heat always transfer from hot body to cold body. Here, iron is hotter than the water. From this diagram, you can see the temperature of iron is 100 degrees centigrade and temperature of water is 20 degrees centigrade. So, iron is hotter than water. So, degree of hotness, coldness is the temperature. Okay. So, it's hotter than water. And heat energy transfer from hot body to cold body. So, the heat energy transfer from iron ball to water. Okay, this is the answer of first questions. Now for the second, let us see which substance, iron or water, has maximum average kinetic energy of the molecules. So look at here, the temperature of iron ball, that is 100 degrees centigrade, is greater than temperature of water, that is only 20 degrees centigrade. So iron ball has maximum average kinetic energy. Okay, as in the definition of the temperature, we have discussed that the average kinetic energy of the substance represents the temperature. So this temperature has the maximum vibrations of the molecules, maximum average kinetic energy. So the average kinetic of the iron ball is greater than or more than the temperature of. So the iron ball has maximum average kinetic energy. Okay, and this is the solution of the second questions. Now we solve the third part. Okay, let us clear it. So in third part we use heat equations. So if the mass of water and iron are 2 kg and 500 gram respectively, then calculate the final temperature of iron and water. So when it is dipped, then there is a transfer of heat between iron and water, and they remains in a constant or the constant temperature, or they have the same temperatures after certain times. Okay, we left them. Then after certain times, the temperature of water and iron ball becomes equal, and that equal temperature is the final temperature of iron and water. We have to find that temperatures. So in the case of third one, now there are two bodies, one is hot, another is cold. So we start from the hot body. So in iron, okay, it is a, we write it's hot body. Okay, so the hot body lost the heat energy. Okay, let the energy, the mass of iron is, say it is M1, and that M1 is, how much is that? 500 gram. So always the mass is measured in kilogram in heat equations. We know that Q equal to M into S into dt, and this is always measured in kilogram. So we have to convert this 500 gram into kilogram. So to convert gram into kilogram, we divide it by kilogram, thousands, and it becomes 0.500 kg. And specific heat capacity, of iron, that is S1. It is also given in the questions. It is 470 joule per kilogram degree Celsius. And another, the difference in the temperature. Now we have to find the change in temperature. Okay, so the initial temperature of iron is, iron, that is T1 is 100 degrees Celsius. And what about the final temperature? Final temperature of iron is to be determined. Say it is T2 and this is, say, suppose X. Okay, X degrees Celsius, you can write. So therefore the difference in temperature is because hot body lost the heat energy. So the final temperature is less than 100 degrees Celsius. That is why we write T1 minus T2, and this equals 100 minus X. Okay, so therefore now by the heat equations. We know the heat equations. Heat lost by hot body or iron. Okay. Heat lost by iron. That is, say, Q1 equal to M1 into S1 into dt. So dt1 we write, because we have another case also. M1 is 0.500 into S1 is 470 into, and dt1 temperature is 100 minus X. Okay, with this, and on calculating this, 2, 3, 5. Okay, 2, 3, 5 into 100 minus X. Okay, we see the data first. 2, 3, 5. Yes. Into X. Yes. This is the Q1. Okay. Similarly, again, in water, that is cold body. Cold body. Okay. Mass of water, that is, say, M2 is, how much is that? 2 kg. And specific heat capacity, that is dt2, specific capacity S2 is 4200 joule per kilogram degree Celsius, and initial temperature T1 is 20 degrees Celsius, and final temperature T2 is X. Okay. Why? The two, body, one hot and the cold, when mixed together, then after some times there is a transfer of heat and the temperature of both body becomes equals. So the final temperature is both X. Okay. So therefore dt2 is equal to, the final temperature here is greater than initial temperature because it becomes hot. It gains heat energy. So T2 minus T1, and this equals to X minus 20. Okay. So after this, we can find therefore now the whole body gains heat energy. So heat gained by water, that is Q2 equal to M2 into S2 into dt2. So the value are, the value of S2, M2 is 2, S2 is 4200, and dt is X minus 200. Okay. So now by principle of calorimetry, we can clear this now. So look at here. By principle of calorimetry, heat gained by cold body is equal to heat lost by hot you can write directly Q2 equal to Q1. Heat lost by iron is equal to heat gained by water. So the value of Q2 is 2 into 4200 times x minus 20 equal to 235 times 100 minus x. Okay, so you can calculate it. And then what do we get this? 8400x minus 168,000 equal to 23500 minus 235x. Okay. So, and now bringing to the left containing x terms 235x, it becomes plus, and 23500 plus 168,000. Okay, yes. Okay, and this total becomes 5, 5, 3, 6, and 8. X equal to, the sum is, how much is the sum? 191,500. 191,500. So, on simplifying this, therefore the value of x is 191,500 divided by 8635. And dividing this, we get 22.177 degrees Celsius, and this means 22.18 degrees Celsius, which is the required final temperature. Okay, so in this way you can find the final temperature of the two bodies when they are mixed together. Similarly, in cold seasons we mixed cold water and hot water, and you can solve such problems similarly by this method. First, calculate the heat gain by cold body and heat lost by hot body, and then equate them and simplify. You'll get the required temperatures. And always note that in cold body it gains heat energy, so its final temperature greater. So the final temperature minus initial temperature. In cold body, the body lost heat energy, so the final temperature is less than the initial temperature. So we subtract the final temperature from the initial temperature. So initial temperature minus final temperatures. Okay, this is case in hot bodies when it lose heat. Okay, this was for today. Thank you for watching the video.